4,700 years ago. Egyptian engineers built a hydraulic system so sophisticated, it would not be matched in complexity. For another 2,000 years, they carved granite boxes with internal corners so sharp and so uniform, modern engineers still struggle to explain how Bronze Age tools could achieve it. And they aligned the Great Pyramid to true north, with an accuracy of 3.4 arc minutes, a level of precision that requires knowledge we are still trying to understand. This is the Egyptian technology we still can't explain. Beneath the step pyramid of Djoser, at Saqqara, lies something archaeologists did not expect to find: a network of underground channels, dams, and water pressure systems that predate any known hydraulic engineering in human history. In 2021, archaeological teams mapping the complex discovered that ancient engineers had built an intricate system using water pressure to transport and possibly lift massive limestone blocks. They diverted underground water sources. They created controlled channels. They engineered pressure differentials. The paradox is this: this technology appears fully formed in 2650 BCE. No prototypes, no earlier versions, no visible trial and error. Just a complete, functioning hydraulic system that would not be theoretically understood until the Renaissance. Nearly 4,000 years later, geoarchaeologist Dr. Judith Bunbury from Cambridge University confirmed that the Egyptians manipulated water tables and natural aquifers with an understanding of fluid dynamics that seems impossibly advanced for their era. So the question is simple: how did they know? Walk into the underground chambers at Saqqara, and you will find something that should not exist. Massive granite boxes, some weighing over 100 tons, carved with internal right angles, so precise they measure within thousandths of an inch. The surfaces are smooth, the corners are sharp, the symmetry is perfect. These boxes were carved during Egypt's Old Kingdom, at a time when the hardest available tools were copper chisels and bronze saws. Granite ranks 7 on the Mohs hardness scale. Copper ranks 3, bronze ranks 4. You cannot cut granite with copper. Mainstream archaeology explains this using abrasive technology. Copper tools combined with quartz sand, or corundum powder, acting as the true cutting agent. And there is evidence for this. Corundum particles have been found embedded in ancient drill holes, imported from distant regions. But here is what remains unexplained: the uniformity. Every drill hole shows the same spiral pattern. Every internal corner maintains the same 90-degree precision. Every surface reflects the same polishing technique. This suggests not just abrasive tools, but a standardized system of manufacturing. One that required quality control, specialized training, and engineering specifications. At the Aswan Quarry, the unfinished obelisk, a 1,200-ton monument, abandoned mid-carving, shows tool marks, identical across its entire surface. Whatever method they used, it was repeatable, controllable, and extraordinarily precise. Modern stonemasons, using diamond-tipped tools and laser guides, still struggle to replicate these internal corners. The Great Pyramid of Giza is aligned to true north, with an accuracy of 3.4 arc minutes. That is less than 1/15th of a single degree. For context, the Paris Observatory, built in 1667, with telescopes and precision instruments, achieved an alignment accuracy of 6 arc minutes. The Egyptians did it better, 4,000 years earlier. Archaeo-astronomer Kate Spence from Cambridge proposed they used the stars Kochab and Mizar, rotating around the celestial North Pole, to establish true north through simultaneous observations. The mathematics work. The astronomical knowledge required is staggering. And it does not end there. The pyramid's base is level, to within 2.1 centimeters across a 230-meter span. Less than 1 inch over the length of 2.5 football fields. Egyptologist Mark Lenner suggests they used water-filled trenches as leveling guides, essentially creating a perfect horizontal plane using water's natural properties. Ingenious, practical, verifiable. But it requires an understanding of geometry, astronomy, and fluid mechanics that we associate with civilizations thousands of years more advanced. Here is what we know for certain. The Egyptians moved blocks, weighing up to 80 tons using wet sand to reduce friction, ramps to gain elevation, and coordinated labor forces numbering in the thousands. Experiments by physicist Daniel Bohm proved that dampening sand reduces drag force by 50%. We know they used copper tools with imported abrasive powders. We know they tracked stars for alignment. We know they engineered water systems with remarkable sophistication. But knowing the methods does not answer the deeper question. How did they develop this knowledge? There are no surviving blueprints, no technical manuals, no preserved schools of engineering. The technology appears, it flourishes, and then it declines. Later dynasties could not replicate the precision of the pyramids at Giza. It is as if an entire body of knowledge simply vanished from history. Some claim this proves the Egyptians had help from advanced civilizations or extraterrestrial visitors. But perhaps the truth is more humbling. Perhaps we have underestimated what human ingenuity can achieve when necessity, resources, and generational knowledge converge. Or perhaps there are chapters of human history we have simply forgotten. Methods lost to time, knowledge erased by conquest, techniques never written down, because they were considered too obvious to record. The Egyptian technology we still can't explain might not be unexplainable at all. It might just be forgotten. If these forgotten chapters of history matter to you, consider subscribing to The Veiled Frame. We explore the questions history never finished answering.